Chaos engineering has proved to be a great option in the SRE and the SDE toolbox, but the transition into more complex systems is accelerating. So I'm Gunnar Grosch. I am a developer advocate, and if it's not super obvious, at AWS. And in this session, we're going to look at how automated chaos engineering can help us cover a more extensive set of experiments than what we can cover manually, and how it allows us to verify our assumptions of over time as unknown parts of the system change. So I think most of you know what chaos engineering is, but it's about breaking things in a controlled environment through these well-planned experiments in order to build confidence in your application and the tools you're using to withstand these turbulent conditions that happen. And we do this to prove or disprove our assumptions of the system's capability to handle these disruptive events. And to do that, we follow this well-defined scientific process that takes us from understanding the steady state of the system that we're dealing with, to forming, articulating a hypothesis, to then running an experiment, often using fault injection. Then we verify the results of the experiment before finally making improvements by learning from the experiments. So we improve the system, and this could be improvements such as the system's resilience to failure, the monitoring, the alarms, the operation of the system, basically the overall system. And today at AWS, we're seeing customers using chaos engineering quite a lot, and the usage is really growing. And we've seen two very clear use cases have emerged. The perhaps most common way of doing chaos engineering experiments is creating what we like to call the one-off experiments. And this is when you create an experiment by, for instance, looking at previous outages or events for your systems. Or perhaps you identify the services that have the biggest impact on your end users or customers if they go down, or if they don't function properly. And then you create experiments for those services. Or maybe you've just built a new feature or added a new service or just made changes to the code or to the architecture. And you create an experiment to then verify that that part of the system works as intended. And we also see that companies are doing this in different ways. Some have dedicated chaos engineers, even though that is a smaller subset of the customers. Often it's the responsibility of the SRE or the SDE even. Or as we partly at least do at AWS and Amazon, chaos engineering is done by the service teams themselves. The ones who's creating the service also make sure that we run chaos engineering experiments on those services. The other common use case is to use chaos engineering as part of your game days. So a game day, if you're unfamiliar with it, it's the process of rehearsing ahead of an event by creating the anticipated conditions and then observing how effectively the team and the system responds to those events. And an event in this case could be an unusually high traffic day, it could be a new launch, it could be an historic failure, or something else. And then you use chaos engineering experiments to run the game day by creating these event conditions and then monitoring the performance of both the team and the system. And doing these one-off experiments and perhaps the occasional game day, it gets us very far on the road to improving resilience. So isn't this enough then to do this? Well, I want to show you an example. So let's just look at a use case example, a simple e-commerce web app. So this fictional e-commerce web app sells a bunch of stuff online. No similarities to any other existing companies, of course. So it has some super awesome architecture in place. In this case, we're running auto-scaling. We have a bunch of instances running across multiple availability zones. We're using multi-availability zone databases. And we're making sure that the system works as intended. And we are then, of course, using chaos engineering to verify the resilience of our system and to learn and gain confidence in the system. And we do these one-off experiments. We create experiments and learn from them. In this group, in this service team, we're of course also using CI/CD practices. So continuous integration, continuous delivery has not only made it possible, but it's even encouraging frequent deployments. So as we know, by doing frequent deployments, the system is less likely to break, as it's more likely that we'll catch any bugs or gaps early on. So our development teams, they are able to deploy faster and more frequently. And frequent deployments, they are hard to cover manually with chaos engineering experiments because things change so quickly in our system. So the other part then is that, well, my service is just a small part of this entire e-commerce web application. We have, besides the product service, we have maybe an order service. We have a user service. We have a cart service. We have a recommendation engine. And we have a search service. And all of these services, well, they depend on each other in different ways. So the cart and the user service, they depend on each other. We have the product who needs to work with the cart and the user, and so on and so on. And besides this, well, 6 services is probably on the low side. We might have 18 services or 24 or 60 services working together to form this e-commerce website. And this is also hard to cover. We don't know exactly what's changing within the application. Just creating this mental model of the system. So with frequent deployments in the system, it's hard to cover manually with chaos engineering experiments. And to cover the extensive set of experiments needed to be able to make sure that our system is resilient to failure is also time-consuming. And this is perhaps time that teams want to spend on doing other things, perhaps creating new features. And even though me and my team, we have full control over our service, the product service, we don't know exactly what changes within the system. Unknown parts of the system might change that affects how my service works. And all in all, systems are becoming more complex. It's hard for anyone today to create this mental model of how a system works, let alone to keep documentation up to date of a system. And this then, of course, all leads us to automated experiments. So automation, it helps us cover a larger set of experiments than what we can cover manually. And automated experiments, it verifies our assumptions over time as these unknown parts of the system change. So doing automated experiment, it also really goes back to the scientific part of chaos engineering. Repeating an experiment is standard scientific practice for most fields. So repeating an experiment more than once, it helps us determine if the data was a fluke or if it represents the normal case. It also helps us guard against jumping to conclusions without enough evidence of the system. So let's take a look at 3 different ways that we can automate our chaos engineering experiments. So the first one, let's just think about how the system evolves. Even though, as I mentioned, we might have full control over our service or microservice, but other teams within our company, or maybe even third parties. They are making changes. They are delivering new code. They are releasing new versions of their services, services that we might depend on. So the verification we got from doing a one-off chaos experiment a month ago or a week ago might quickly become obsolete. So by scheduling experiments to run on a recurring schedule, we can get that same verification over and over again as these unknown parts of the system changes. So I want to show you an example of how we can do that. And I'm going to use AWS Fault Injection Simulator, obviously. But the thing that I'm talking about, it relates to any kind of experiments you're doing, and you can do this no matter the tooling or the way you're approaching chaos engineering. So this is Visual Studio Code. So what I'm going to do is basically use an AWS FIS experiment and schedule that. And I'm doing a simple scheduler by using a serverless scheduler, setting up an AWS Lambda function, and then setting up a schedule to run this experiment over and over again. So we're setting up a schedule. We are using a simple AWS SDK to call the AWS FIS service on that schedule. We're providing it with an experiment template that I've run before and simply calling a start command to the AWS FIS service. So with that simple scheduler in place, I can then run my experiment towards my, in this case, EC2 instances running in the application using that experiment template that I've created. And let's just create an experiment template to begin with using the AWS CLI. With that, I'm getting an output, an ID of my experiment template. I can copy paste and simply just update my scheduler to use that experiment template. Just running through the very quick guide, pasting my experiment template ID, setting my schedule, in this case to run, who's expert on cron syntax, twice a day, I think, maybe once. And then deploying that. This will now update my scheduler with that experiment template. Looking in the AWS Lambda console, we can see that it's been updated. Cool. So then we could either wait for 12 a.m. Or we can simply just test the scheduler. So I'm going to create a test event, copying the test event, and let's just run it through the AWS Lambda console. And this approach, as I mentioned, I'm using AWS FIS. You could use it with any type of chaos engineering tool or library that you wish. It's executed. So if I switch over to AWS FIS, we can see that my experiment is now running. And with the experiment running, it's going to complete all of the actions I have in my experiment. In this case, increasing CPU load to test how does my application behave when EC2 instances are experienced higher CPU load. And if all is good, the experiment will complete. And we have then verified how the system works. This experiment will then run on that schedule over and over again and verify our assumptions over time. The second approach to running automated chaos engineering experiments is based on events. So an event, well, that's basically anything that can happen within your system. This could be an event related to the tech stack, for instance, that latency is added when there's an auto-scaling event, when new instances are adding. Or maybe it's a business-related event, like an API being throttled when things are added to the cart. Or finding other ways, things that happen in your application. So building automation around these types of events, well, it helps you answer those kind of hard to answer questions. What if this, when that is happening? Even when the that, in this case, is another part of the system. Then the third way of doing automated chaos engineering experiments is perhaps the most popular one so far, and definitely the one I'm getting the most questions about. As we said, continuous integration and continuous delivery, it makes it possible and encourages frequent deployments. And as we know, frequent deployments are less likely to break. So we're adding chaos engineering experiments as part of our delivery pipelines. So we're able to continuously verify the output or behavior of our system on each code deploy, on each code change. So let's do a demo of that as well. So this is AWS Code Pipeline. I have the most basic of pipelines set up. So we are fetching a source. We are then building that source, and we are then deploying it to the staging environment. So let's just update our stack, and add an experiment template. So taking one of our experiment templates, one that we've done as a one-off experiment, CPU stress in this case, adding that to our CloudFormation stack, and quickly running through the wizard to update our stack. This will then update my pipeline. And scrolling down, we can see that it's now added an experiment on staging stage in the pipeline. Meaning that after deploying to staging, we will then run an experiment on that environment. And what it does is kicking off a workflow in step functions that's basically starting an experiment, then waiting for the output of the experiment before sending a signal back to the pipeline. So let's release a change. Releasing the latest code change once again. So we're fetching the source from code commit. We are then building that source, running all of the tests that we might have there. We are then deploying this new code to our staging environment. And as soon as the deployment to our staging environment is done, it will kick off the experiment stage. Meaning that it will start our AWS FIS experiment. As we can see, it started the experiment. It is now waiting for the output of the experiment before sending a success signal back to the pipeline. As soon as it's done that, it will then go on to deploy that same code to our production environment. Because we have seen that this code change, it has succeeded with the chaos engineering experiments that we've done. So with these recurring scheduled experiments, with event-triggered experiments and continuous delivery experiments, we have 3 different ways to automate our chaos engineering experiments. But to get to the point where we're confident enough to run automated experiments, I think we really need to fully embrace the idea of safeguards, which is a way to monitor the blast radius of the experiment and stop the experiment if it sets off any alarms. So safeguards and stop conditions, they are key for successfully running automated chaos engineering experiments. So one final demo to show you that. I want to show you how we can use safeguards to make sure that the automated experiments we're doing are not causing outages. So we have an alarm set up in CloudWatch. For a production environment, we'd probably have more than one, but one is enough for now. It's in the OK state, as you can see. Then we'll just update one of our experiment templates and add this alarm, CloudWatch alarm, as a stop condition. just confirming our instance, and then finally adding it as a stop condition. And with that, it means that if these alarms are triggered during our experiment's runtime, it will then stop that experiment. So now we have that in place. We can then move back to our pipeline and think about the automated delivery pipe experiment that we ran. And let's just make an update. As one does, we'll just update it straight in the Git repo and make a change. This alarm is checking for the title of the page, but it could be checking for anything, basically. So we're just setting it to the wrong title. So when this monitor is checking for the title of the page or checking for an error, it should then hopefully find that it's not working. So it fetched the new code, it's building the new code, and it's then going to deploy that to our staging environment. And as we know by now, as soon as it has done that deployment, it's going to kick off our experiment. So now it's running the experiment. The experiment is running. Looking in CloudWatch, we can see that the alarm is still in the OK state, and it's moved into the alarm state because there was something wrong with that page. It triggered an alarm. That then stops the experiment that we're running in AWS FIS. With the experiment stopped, that's then going to send a signal through our workflow back to the pipeline. This experiment failed. Something is wrong with the code that we just deployed, meaning that it's going to fail the pipeline. Also meaning it's not going to take that same code, that same artifact, and push it into production. So by doing this, including these experiments in our delivery pipelines in a safe way with stop conditions, with safeguards, we can make sure that we're running those chaos experiments continuously, but in a safe way. So code that is incorrect or faulty does not get sent to our production environment. And as our confidence in this grows, well, we can start promoting these experiments into production as well and run the same type of experiments on each code deploy into production as well. So with this added use case of automated experiments, I am definitely not saying that you should stop doing one-off experiments or the periodic game days. They should still be the core of whatever chaos engineering practice you have. They are a super important source for learning, and it helps your organization build confidence. But this is yet another tool to help you improve the resilience of your system, the automated chaos experiments. And one way I like to think about it is that the experiments that you start off by doing as one-offs or in a game day, they can then turn into these experiments that you run automated on a schedule or on each code deploy. Some quick takeaways in the summary. Automation helps us cover a larger set of experiments than we can cover manually. And the automated experiments, they verify our assumptions over time as unknown parts of the system are changed. And the safeguards and the stop conditions, they are definitely key to doing safe automation. And finally, introducing automation in chaos engineering does not mean that we should stop doing manual chaos engineering experiments. If you, like me, can't get enough of chaos engineering, then I've gathered code samples used in the demos, some more reading material resources on the link shown on screen right now, so you can just scan the QR code or enter grosch.link/autochaos. And with that, I want to thank you all for joining today.
Thank you, Gunnar. Any questions?
Thank you. So if you were developing a new platform, brand new greenfield, everything beautiful, following all the wonderful design principles, etc.
Yeah.
Would you start introducing chaos engineering from the beginning as a way to maybe potentially also inform on the architecture and observability, or would that be overkill and you would do it later?
It's a bit of a leading question that leads me to the answer yes. I would, because I find chaos engineering as a great way to verify that the things you're building actually work as intended. The most basic of examples is you're using auto-scaling in your architecture. Well, then you can do chaos engineering experiments to verify that the auto-scaling works as you intend it to, that it scales quickly enough or that it's replacing instances correctly and so on. So yes, I would introduce it early on. It doesn't mean that you have to spend a lot of time on it, though. You can do these quite simple experiments and do those to verify your assumptions of the system.
Thank you.
Just wondering how much effort and reliability we would get if you're unable to run chaos engineering on production. Say, for example, it's trading floor software, and you are in the middle of upstream and downstream services where it's purely mocked, and you're not entirely sure what the disaster recovery is of those services.
So, what was the question?
Just wondering how much effort and reliability you can really get from chaos engineering if you are in the middle of a cog in a giant system.
Well, I think you can learn a lot from it. One of the most common outcomes of any chaos engineering experiment, in my experience, is the unknown. You find these unknown parts. You find perhaps that the system is less reliable or sometimes even more reliable than you expect it to be when doing these. And especially on the parts of the system that, as you say, it's somewhere in that system, like one cog. So I would say that it is a great source for learning for that kind of part of a system, even though you might end up not making any changes based on it. But it's about building that confidence and learning about unknown parts of the system.
Cheers.
Any other questions?
More like a generic question. What would be your criteria to define which experiments to set up? I mean, I can imagine with the project I serve, there are hundreds of criteria, experiments we can set up. Which ones gives me most benefit of added value to invest in?
I have to give the standard solutions architect's answer to this. It depends, because it really does. I think what I tend to see are two different paths usually. One is the easy path. Just find the things that you are quite sure of and just verify those, like a way of ticking off boxes. I'm quite sure that this works in this way, and you do it as a way to just confirm those things. The other one is to lean more towards the unknown, to create those experiments that are more about the unknown parts of the system. So either or in that direction is usually what I see, without giving a suggestion for you, because it depends.
I have a question on how you kind of implement. So I think in Amazon, what you said, I think is the service team who plays the role of SRE and kind of run these experiments during that design phase and kind of development delivery phase. But I've seen the different model in Netflix and Google where they have a dedicated central SRE team which kind of runs things. So what's your observation on to scale things, whether it should be a federated or should be a central team running this chaos experiment, and what are the learnings out of this?
The approach that we're taking at AWS and at Amazon is to have the service teams. They are autonomous, own their service, and they also then own the resilience of that service. I think that is very good from an ownership perspective because they own it. You build it, you run it, you own it. But for other companies, you mentioned Netflix as an example where they have chaos engineers doing and running experiments. I think that has worked really well for them. So I don't think there is a clear answer of how to do it. I would say that starting off by adding it as a new role is probably harder and more complex than adding it as another tool in the toolbox for the existing people. So if you have existing SREs or you have SDEs that are, I don't know, chaos curious, well, maybe that's easier. CC, chaos curious. So yeah.
Hi. So would it be a good idea to include chaos engineering as part of your DR strategy?
Two fields that are very closely related, and it's a common topic of discussion with this entire resilience umbrella. They all fall as maybe separate parts under that same umbrella. So depending on the organization, using chaos engineering as a way to verify your DR strategies is definitely a good way of approaching it, I would say. So it could be like a game day where you're testing your DR strategy and you're using chaos engineering as a way to do that scenario. Out of time?
Any other questions? Okay, I think we've got the last one.
How would you convince a senior or management that chaos or introduce that, because that chaos engineering implementation would need extra effort and resources? How would you convince them?
I just had a conversation about that with the SteadyBit team. We talked about the different approaches to how to tackle this. And the top-down approach, convincing leadership about the value of these practices, I think that's key to doing it successfully. Sure, you can have teams that start doing this and then you prove it to leadership, but having that top-down commitment, I think it's important. And it's all about talking about these important keywords, resilience, reliability, and then looking at what happens if we don't have a resilient system, if we don't have reliability. For leadership, it often comes down to that. What happens if we have an outage, for instance? So calculating the cost of an outage might be a way to help them be convinced.
Yeah. And pro tip, don't call it chaos engineering. All right. Thank you very much.
Thank you.